Hello, grade 10. I hope your Monday is going well. And I hope that my weekend went well and that I'm coming back to you with a trophy. And if I'm not, then I hope I'm coming back with at least some good stories about how your classmates played valiantly in the tournament this weekend. Today you're going to be learning about two new things that you've never done before in math. You're going to be finding domain and range of a relation. These two things are very, very important, especially if you are a person who is taking the pre-calculus route and hopefully the calculus route through high school and university. These two ideas help us to understand what kinds of numbers, what kinds of values the independent and dependent variables in a relation can take on. So if that sounds a little bit wordy and a little bit confusing, I'm going to use the example that we did last day to help explain what that means. So you'll remember Jorge from last day, our little frog friend. Maybe I'll draw a little picture of Jorge. I have to be honest, I've never tried to draw a frog before. This is my first attempt. Okay, looking good so far. There you go. I guess frogs like to go in the starfish position sometimes. Because they also have fingers. Don't they have like big fingers? Hairy fingers. Alright, a frog with hairy fingers. And of course a tongue. Can't forget that. So there's Jorge. He was our frog championship, jumping champion frog. He could jump a distance of 2 meters, and we looked at 5 different ways to represent this incredible amphibious ability. We demonstrated that relation in a graph, in words, in an equation, in a set of ordered pairs, and in a table of values. Think back to the equation that we had last day. We had this equation d equals 2 times n, where d was the total distance that the frog jumped, and n was how many times he had jumped. And we had determined that d was the dependent variable, and n was the independent variable. Okay? And the reason why we said that was because d, or the value of d, depended on the value of n. How far the frog jumped depended on how many jumps he took. Right? The independent variable, its value was constructed just by the context of the problem. When the equations don't have context, you can just choose values for the independent variable at your will. But in this case, they're just determined by the behavior of the frog. But the distance is dependent upon the number of jumps that the frog has taken. Alright, so that was the equation that we had last day. I want you to think, just for a moment, about the kinds of numbers that n and d can be, given the context of our problem. What kind of numbers could these variables represent? Right? And while you're thinking about that, think about these questions. Think, could d and n be positive numbers? Could either of them be 0? Could they be negative numbers? Could they be fractions or decimals? Right? Maybe one of the obvious answers to one of those questions would be that they can be positive. Right? I can have a positive number of jumps. I could, find out how far the frog jumped after 5 times. That would be a positive number. And that would generate a positive 10, a positive distance for d. So, okay, n and d can both be positive. Could either of them be 0? Well, n could be 0 if the frog just didn't start jumping yet. Then d would also be 0, so yeah, they could be 0. What about negative? Could n be negative? Can the frog jump a negative number of times? That doesn't really seem to make sense. And D, can he have a negative distance? Well, technically no, because he can't, he can jump backwards, I guess, but you could still plot where he started from to where he landed as a positive value. Distances, I guess, are always positive. You wouldn't say he jumped -3 meters. Right? You're just trying to track for where he started and where he ended, and that's always a positive value. What about fractions or decimals? Could n be a fraction or a decimal? Well, like we mentioned last day, this is a discrete relationship, so n couldn't be like 1.73. We couldn't measure his distance after 1.73 jumps because we only measure the distance of the frog after every single time he lands, after every whole number of jumps. Okay? So, these questions that I asked you lead us to the idea of domain and range. All right? Again, these are very, very important words, especially in the field of calculus, and we're going to define them here. Okay? So domain, by definition, is the set, make sure you write this down please, the set of all possible values for the independent variable. Okay, that's just another way of saying the domain of a relation is all the numbers that the independent variable can be. Right? So some of the values in our domain here could be 0, could be 1, because you could jump once, 2, 3, 4, and so on. These are examples of values that are in the domain, but to state the domain properly, we have to list all the possible numbers that n could be, or the independent variable. Range is similar, except that it talks about all the dependent values. Right? So the range is the set of all possible values for the dependent variable. And I can see I forgot the word variable here. Okay? So in the frog instance here, the range would be all the possible numbers that d could be. Right? So some examples would be 0 is if the frog hasn't gone anywhere, 2 after 1 jump, 4 after 2 jumps, 6 after 3 jumps, 8 after 4 jumps, and so on. Again, that isn't the entire range, but it gives you a sampling of some of the numbers that are in the range. So, hopefully that makes sense. Just remember, domain is the set of all possible values for the independent variable. That's all the numbers that this guy can be. And range is all the possible values that the dependent variable can be. That's this guy over here.